Okay, you're ready.
Thank you.
So my name is Tate, and I work at the UK Polar Data Centre here at FAS. I'll be talking today about the data management systems on board the newish UK research vessel, the Sir David Attenborough, or the story so far about it. So my co-conspirators on there, most of whom are within the data centre. But there are other individuals there, so Jeremy, who works within our IT team, and Juan, who's on there. He is a representative of a larger development team at the National Oceanography Centre. So we developed some of our systems with them, so they represent the other UK research fleet. What the people who aren't on there, who are very, very important to this, the data management systems are at kind of the end of a very long pipeline, from the commissioning of the vessel all the way through to the sensors themselves. So they involve a whole bunch of scientists. I've just seen Sophie arrive at the back of the room, and other IT individuals. We have mechanical and electronic engineers. All of these people, lab managers, are essential to getting the systems to the point where data flows out of them and data management. And obviously, we managers get involved in those processes, but we're fully reliant on many, many other individuals. So that's a key point to make. Gone down already.
Oh, turn on the side. It saves battery, so.
Well, so there it is, living its best life out in the Southern Ocean. I haven't put any of the vital statistics on there because Wikipedia's got all that. Find all that. It's very long. It's very heavy. I can't lift it. Although don't believe Wikipedia, because it does say it's got 2 helicopters. It doesn't have 2 helicopters. And the helideck is primarily for my benefit for running round and round. The thing you need to know, it is not quite as red as it is in that picture. What else could you say about it? Yeah, so the one take home, if we're not going through the data systems, is in the time it's been there, that one of the take home messages is it's a very comfortable ship, and that is a brilliant thing to, when you get that kind of confidence, very comfortable. You definitely want to be working on a comfortable ship. The food isn't better. So so this vessel was the kind of the government announcement came out in 2014. It started to build, process the keel laying was in 2016. And the important fact is that it replaced 2 billion. So that's James Ross, which is our scientific vessel, predominantly science, and the Shackleton, which was a logistics vessel. So this is an attempt to do both of those things in one vessel. The 1 for 2 deal, kind of less is more type situation. But in terms of timeline beyond that, and timeline that is more important, I guess, to the data systems, is the things that have occurred from late 2020 onwards. So we came out of the yard in late 2020, went through sea trials, and their trials that just made sure that the ship stayed afloat and could go in the right direction when it was prompted to do so. We then progressed through to winch trials, which is, as on board vessels know, are incredibly important to any kind of science that involves different deployments, and they can bedevil research vessels. By and large, the winches have worked very well. That's great. So that was something that were initial winch trials. It then hot-footed it down for its first season south, because by that point, there's big stations hadn't eaten for several years. So it needed to get down there to do resupply and things like that. So that was its first season south at the end of 21. It progressed then onto ice trials, down the bottom, which is a chance for it to prove its ice capability in fast ice and sea ice. We're moving on to stuff that occurred last summer. So we ran the acoustic trials. The ship has got a large number of acoustic systems. Acoustic trials aren't so photogenic, so I have to picture from this is looking out from Macduff in northern Scotland, but that's more to prove that you can sometimes get blue sky days in northern Scotland. We then progressed through to the polar science trials. So now we're at the start of this year. and they were certainly, well, there were certainly signs. This possibly were trials, but they were definitely, they were a rehearsal crew as well. I'll get onto that later on, because that was the first real big test of the data systems that are there. And then we're almost on to the present day. So this summer, we've got a bunch of other trials, so workboat trials, a moon pool, that was trials, and coring facilities trials and stuff. And because I can't see in the future, I haven't got a photo for this December, but December we'll see the first funded science that goes on at Petrius, supporting that for data management purposes. But that is, you know, all of this has progressed forward through to a point where effectively paying scientists will be on board, you know, doing real funded science. So when I say, so in that time, we have developed data systems that sit on top of scientific systems, and these are an array of groupings of systems. There are far more that I can describe individually, but these are the kind of groups that we've got. So we've got position and attitude sensors, your GPSs and your motion reference units, surface ocean, metadata, air sampling, and you take those kind of as an umbrella group of underway data, so they're data that can be continuously measured all the time when they're on. But then you get into the more discrete measurements through deployable systems, profiles like CDD, sampling systems, whether that be sediment or water. I guess CDD collects water, ice, that kind of thing, through to the acoustic suites, which there are a huge number on board the SDA, from multi-beam, single beam, metric echo sounders, through current profilers, through to a huge number of bioacoustic. And images, I couldn't quite take time to find one of the images that we actually send down, but there's an image from a webcam, which is an example of an image, so images and videos and things like that. Increasingly, there's lots of platform monitoring. So that's monitoring of the vessel and its function as it is. And then you come to things that may, lots of what I've described are always on the vessel. Then you've got things that may come on for periods of time and then leave again, usually on a period basis. So things like people bringing lab equipment for analysis purposes, and also autonomous systems that may come on and off the vessel. So if we look at the underway systems, so the things that are producing data all of the time, this is just a schematic to say how we deal with this. This will be very familiar to anybody who's here for the first 2 days, because this is very similar to virtually every underway data logging system. The elements might be different, but the actual workflow is the same. So we start out with our sensors. Most still are serial based, so we bring them through a bunch of hardware devices that get them onto the network. Some newer sensors are network ready, already, so that straight onto the network. We translate where necessary the messages into some form where there's some form of then standardization, and then we bring it through. So the central part is the primary data log. That is called RVDAS, which everyone else also calls, because it stands for Research Vessel Data Acquisition System. There are other RVDASs out there in the world. And because we love acronyms, the acquisition module of it we call RAM. If you can ever acronymize something at BAS, you're a winner. If you can take an acronym and stick it into another acronym, then you're really onto a winner. So that the acquisition module is listening for the messages coming over the network, and the first thing it does is it takes a timestamp. It timestamps it as soon as it can, and it writes that to file and sends it on to an ingester module. The purpose of the ingester module is to effectively get it into a database form as soon as possible. So we use Postgres with a timescale DB extension, so it's a time series specific extension, so it can deal with the billions and billions of data points that will build up over the life. I mean, we already have billions and billions of data points, go on and on. And from there, we use Grafana to then visualize the data. The separate section on the right just is there to say that we also run NOAA's SES software. So that was software that we used previously on JCR to the James Clark Ross, and we use that in a completely backup facility. So if the entirety of our primary data logger went down, the SES would be working in the background, and we would have some god-awful process to get it from one to the other. But we could do that. We wouldn't have lost data. So just in terms of the history of the systems as they've come online, this is just a Grafana graph. So the you don't need to take account of the details along the bottom, but they're all the systems, and the along the x-axis is time from about 2001 to the present day. So as time's gone on, systems have been commissioned, and this is kind of a present absence of them. As you can see, more and more have arrived. I think when Elise was on board a few weeks ago, we managed to get all the systems recording all at the same time. So we had 60 plus systems, and so that is kind of the line towards the end. And I mentioned data visualization. Once obviously you have all that data feeding in, again, it's common to most of the data logging systems, you have the ability to then report that in real time, and to be able to go back historically to use any kind of data source. But Grafana is really good at showing real-time information. So this is an example of an overview that is used on board the vessel, and it's become incredibly successful. This is to many people for on-board purposes is the front end. This is the data logging system. This is the what people see of it. So giving people easy access to real-time values to make operational decisions on board. So some of the other things that we did at the same time, and where data logging system is the entirety of a data management system on board the vessel. We talked a lot on Monday and Tuesday about contextual event logs, so not just what the sensors are producing, but what humans say about the sensors or the deployments, whether they start, whether there's issues, those kind of things that give context to the data itself. We had an event logger on our previous vessel on the James Clark Ross. That was provided by Jeremy, who was the initial developer of it, and so it was integrated with the SDA data streams and made available on the new vessel. And it has, just like the old version, it has been very well used by both scientists and crew. And the reason it's used by everybody is it's incredibly flexible, and that flexibility has slight drawbacks. And I've mentioned in the third point that the standardization that you get as part of what you would expect the data management elements, or adding vocab terms and making sure that the data that goes in is consistent cruise by cruise. That is done through effort, usually on the part of the data managers on board or the principal scientists, rather than it being baked into the design. But we have to be very careful when we do eventually redesign it, that we don't kill the usage by making it suit data managers and not end. That is a really important thing that we need to take into account. And then, as a kind of a separate but comparable activity, Petra and I were involved with others around internationally to come up with some new vocabulary terms around events, processes, and actions that we described. Some of that we described on Monday and Tuesday. So the metadata is obviously a massive element in terms of interoperability, and we have, as time's been going on, we've been compiling the metadata for all the systems and sensors that we've been commissioning them, and we've been adding new sensors that are new to the vocabulary service. We've been adding them, submitting them to the vocabulary service, and they've been added as time's gone on. So all of the ones that we've needed codes for have been added. Other things we've done. Data that is not doesn't go through the underway logging system, that's maybe too complex, like acoustic data, that requires synchronization, so it takes off the central storage area network. So we've been doing that. That's very analogous to OpenVDM, which was described Monday and Tuesday, using arsenic scripts. We still use post-cruise tape backups to get the big volume of data back from ship to shore. Look at change that in the future. In terms of data access, standardized structures on board the ship, access to daily underway files, database tables, post-cruise data archives available to cruise party. The main thing that's outstanding there is the fair access to underway data, and I'll touch on that in a minute. And documentation. And that's been a big thing. It's a new vessel, completely new to both us as science support teams and the users. So there's a lot of assumed knowledge that is now irrelevant from the real vessel. That all needs to be rewritten, new ways of working. So we did all that work. Was it enough to pass the test of the Polar Science Trials, which occurred earlier on this year? So the Polar Science Trials was effectively a rehearsal cruise. It had a number of project teams, scientists. It was a decent length of time. Lots of data was collected, as you can see there. It was real in the sense that people didn't treat it as a trial. People treated it. There were people on there who definitely were going to do useful things with that science. So it was very similar to a normal business as usual cruise. I put at the end that myself and Elise were both supporting that. It was an intense cruise, 24-hour working, as most normal science cruises are. Most of our kind of our baseline things we didn't lose any data. Most people got the data they wanted out of that cruise. There's huge amounts to do, but I believe that the data systems held up for that particular test. But there's a huge amount still to do, massive amount. I've named a few things on here. Most of the things I've mentioned have got multiple iterations to go forward. The event data model doesn't quite represent everything that it should do. We developed an in-house data model. The underlying data model it needs a revision. It needs to reflect lots of the work that's been done internationally through things like observation and measurements, those kind of international type standards. We need to get our sensor metadata into some structured format so it can then be much more easily added to the data and structured files like SCDF, that kind of thing. We can now potentially sort out real-time ship to shore. We could always have done this. We have VSAT link like everyone else, but we are starting to bring Starlink type communications on board, so that is a whole new level of the ability to bring data back in near real time. I mentioned the fair data access to raw data. We already have a pipeline of getting data out to the British Antarctic Data Centre. So the kind of long-term data management. So I feel that as a ship operator, we can do much better in making the raw data available much more quickly with the permission of the British side. There are still sensors to be integrated in. We haven't quite finished. There are still things that are outstanding. The Grafana dashboards could take up our lives if we wanted to. I could expand visualization. There's almost no end to what you can do. Documentation is a big thing. And there's some big elements at the end. Amidas version 2, so a rethink of the underlying concept behind how we set up the pieces of the underway data logging system. And there's a poster available for folks to look at and Postgres improvements. Some observations. I'm running out of time. Yeah. After saying that, I'll only end in 10 minutes. Data everywhere. Everything. All sensors are providing data. Things that you would never imagine providing data are providing data. And we're getting lots more requests for data for operational purposes, for things that probably weren't being asked for before, for net zero purposes, things like that. Low Earth orbit, Starlink will change things massively. Opportunistic data collection. I have this naive view that all sensors should be on all the time, but the reality is that can't happen for a variety of political and diplomatic clearance reasons, and just resource for having people on board that can support those systems. And autonomous marine platforms are the future. I keep getting told that, and I'm like, oh, I'm on a vessel. I'm doomed to fail here. It'll be gone. But despite that, vessels, marine vessels do still have a future that's very difficult to see, at least a short-term future where autonomous vehicles could provide the kind of lab capability that you have on board, something like the SDA and some of the very large bits of kit and power requirements that they would need. So I see, and also platforms, vessels are platforms to deliver those autonomous vehicles to remote locations, still massively important. And that is it. Finished. There's my regulation sunset. There's another blue sky in northern Scotland. Thank you very much.